Hi, my name is Matt Diederick, and I am presenting my route mining application for CIS576. The user interface. The route mining application allows a user to load a file containing address information, such as a street, city, state, and zip code. It also allows for the addresses to be displayed after being validated for accuracy and having a carrier route associated with it. It also contains a display for an aggregated list of counts for each carrier route. The user also has the ability to save the addresses with the carrier routes and the counts per carrier route list to a file. The user clicks the open file to browse or enter a file path containing addresses to validate and display. The API attempts to correct errors in the file and also appends the carrier route for the addresses. The user clicks the Save Addresses button and is prompted to enter a file name to save the addresses with carrier routes too. The user clicks the Save Carrier Route Counts button and is prompted to enter a file location to save the aggregated carrier route count list too. I'll now demonstrate the functionality of the application. I will click the Open File button and browse to a file location. Select the file, and here we can see the appended street, city, state, zip code, and the added carrier route to it. And here we could see the aggregated list of carrier route counts. For this carrier route, there's 2 in the list, so it displays a count of 2. In this one, the API was unable to find a appended carrier route to the zip code, so it does not have a carrier route to it, and that one only has 1 in the list. I will demonstrate saving the addresses to a file. By here, we will enter a file name, save address list, and that will save to a file. And here we could also do the same for the carrier route counts. Save carrier list, and we could browse to that location and see that they are saved. There's the carrier routes, and here's a saved address list. We could also open a new file and it will change the list. As so. I will now discuss the design of my application. The main component of the application is the address reader abstract class, and this represents the user-facing interface, the user-facing API for reading in addresses. And it contains a abstract method called readAddresses that takes a file name as a parameter. And it delegates the actual task of reading in the files to classes that implement the iAddress file reader interface, which actually does the main work of reading from a file. And there's 2 different types of files that the application can read from: a CSV file and Excel files. And these are the actual work of reading from these types of files is handled by the CSV address file IO handler and the Excel address file IO handler. There's 2 concrete component classes that implement the address reader class that handle that are facing the user to actually read in CSV files or Excel files. And these are called CSV file address reader and Excel file address reader. And since these take a implementation of the iAddress file reader, for the CSV file address reader, a CSV address file IO handler is passed into the constructor to actually do the work of reading in the files. Likewise, for the Excel file address reader, a Excel address file IO handler is passed in as a dependency to actually reading the files. And for validating the addresses, we use a wrapper, also known as a decorator, that extends the address reader class, but is also composed of an address reader in order to wrap it, and actually calls out to a address validator class that handles the task of calling out to the web API to actually get back the valid addresses as well as the carrier routes. And the address validator implements the iAddress validator interface. The design patterns this design uses. The overall user interface design is structured using the model view model design pattern, also known as MVVM. And the actual business logic is structured using the bridge, decorator, and singleton patterns. The bridge pattern, the design uses the bridge pattern to separate the client-facing abstraction that the user calls upon to read the addresses from the implementation that actually does the work of reading the addresses from a file. The bridge pattern allows the abstraction and the implementation to be deployed independently, and the client code can access only the abstraction part without being concerned about the implementation part. Here we can see just UML for the bridge pattern. We have the address reader class that is the abstraction. Then we have two refined abstractions that are the CSV file address reader and the Excel address file reader. And they both implement the abstract read addresses method. Then we have a implementer that actually represents the interface for actually doing the work of reading in the files. And it contains a single abstract method called getAddressesFromFile. And that has two concrete implementers that actually represent doing the work, called CSV address file and IO handler, and Excel address file IO handler. And here we'll further explain that. The application contains an abstract address reader class that represents the abstraction part of the bridge pattern. This class contains a reference to the implementation interface that does the real work. This contains an abstract read addresses method that subclasses must implement. The application also uses CSV file address reader and Excel file address reader classes that inherit from the address reader class. These represent the concrete abstraction component of the bridge pattern. The implementer interface component of the bridge pattern is represented by an iAddress file reader interface in the application. It contains one method, getAddressesFromFile, that the concrete implementations CSV file address file IO handler and Excel address file IO handler implement to retrieve the addresses stored in each type of file format. The design furthers this by implementing the decorator pattern to allow for additional behaviors to be added to objects. In this case, this allows for additional functionality to be assigned to the user-facing abstraction, which is the classes that extend the abstract reader class. The address reader class represents the abstract component of the decorator pattern, and the CSV file address reader and Excel file address reader classes represent the concrete components. The base decorator piece of the decorator pattern is represented by the abstract address decorator class. It is a subclass of the address reader component and is also composed with an address reader type member in order to wrap the address reader and add functionality to it. This allows for subclasses to wrap address readers and add additional behavior. The validation address reader decorator represents the concrete decorator part and adds the additional behavior of validating the addresses after being input. Lastly, we use a singleton pattern in two places. The address validator class is used to call out the API and return a validated address. The validation address reader decorator class is composed with an address validator. Since this class performs expensive web API calls, it makes sense for only one instance of this class to exist. The application event aggregator, which is part of the UI, also implements the singleton pattern to allow only a single instance. This class is used to publish and subscribe events and pass data between views. These classes are made up of a public and private static instance of the containing class as well as a private constructor. The public instance checks if the private instance is null, and if so, it sends a new instance to it. This returns the private instance. Well, now I'll take a look at this in my code. Here we can see we have our view models, which is our address and carrier route count list, and our view models, which allow kind of hiding the data from the views itself. And lastly, our different views, which is our buttons and our address list and carrier route count list. This kind of composes the MVVM pattern I mentioned earlier, which handles UI work. And here's a look at our address reader abstract class, which represents the abstraction and in the bridge pattern and the component in the decorator pattern. We can see it's composed of a implementer reference, which is the iAddress file reader class that actually does the work of reading in the addresses, as well as its abstract method to actually read in the addresses. And next we will look at our CSV file reader. This class represents the refined abstraction in the bridge pattern and a concrete component in the decorator pattern. And it extends the address reader class. And my Visual Studio closed. Alright, here we go. We will continue looking at our address reader. Our CSV file address reader class. And this extends the address reader class and is composed of a CSV address file IO handler, which actually does the work of reading in CSV files. And it uses that file IO handler to implement the read addresses method in the address reader. And that returns a collection of addresses. Likewise, the Excel file address reader does the same thing, except it's composed of an Excel address file IO handler that does the work of reading in Excel files. And here we'll look at the address file IO handlers, which represent the concrete implementer part of the bridge pattern. And these implement the iAddress file reader class, which is the implementer interface. And these contain a single method that is part of the implementer interface to actually read in CSV files, in this case. This also contains the logic for writing addresses to files, as well as carrier routes to files. Likewise, the shell address file handler is a concrete implementer that implements the iAddress file reader interface and handles the work of reading addresses from Excel files in this case. For our validation, we have a iAddress validator interface that contains a single method of validating an address. This is implemented in the address validator, which implements the iAddress validator interface. And it also is a singleton to only allow a single instance of this class that calls out to the web API. Here we have our private static instance, as well as a lock to make this singleton thread safe. Here we check if that private instance is null, and if so, we create a new address validator and then return that private instance. And we have our code for calling out to the web API here. We use a build street API. Here's our private constructor here. And this is the implementation of the validate address class here that actually calls out to a web API and gets back a address here that is composed of a carrier route that is returned by the API here. And the validation address reader decorator uses that address validator to wrap a concrete instance of an address reader with the ability to validate addresses. But so you look at the address reader decorator abstract class first, and it implements and it extends the address reader abstract class and is also composed of a address reader. This allows us to wrap the address reader abstract class. And we will implement the read addresses here to use the address reader that is supplied to us to the constructor to actually read in the addresses. Then in the concrete implementation of this address reader decorator, we will extend it by adding the behavior of validating the addresses, which is what I showed you of actually calling out to the web API. It uses that address validator class to actually call out to the API, reads in the addresses, then it calls the address validator to validate the addresses, then returns us a collection of validated addresses. And that's it. Thank you.